Question 1, Part C. Find the integral of sin³ x over cos² x dx. There are two methods that can be used to integrate sin³ x over cos² x. In the first method, we can use a Pythagorean identity to express sin³ x in terms of sin x and cos² x. And in the second method, we can use an appropriate substitution. So let's go through the first method. We're going to use a Pythagorean identity to express sin³ x in terms of sin x and cos² x. Now, sin³ x can be written as a product of sin² x and sin x. Now, sin² x is 1 minus cos² x. So sin³ x is equal to 1 minus cos² x in brackets times sin x. Hence, the integrand sin³ x over cos² x can be written as 1 minus cos² x in brackets times sin x all over cos² x. Expanding the brackets in the numerator, we get sin x minus sin x times cos² x over cos² x. And that simplifies to sin x over cos² x minus sin x. Since we have some cancellation here, so the cos² x here cancels with the cos² x here. And then we're left with sin x over cos² x, which is this term here. Now, sin x over cos² x is sec x times tan x. And we take away from that sin x. So the integrand can be written as sec x tan x minus sin x with respect to x. So performing the integration, the integral of sec x tan x is sec x, and the integral of sin x is negative cos x. So the integral of sec x tan x minus sin x dx is equal to sec x minus negative cos x plus the constant of integration c, which simplifies to sec x plus cos x plus c. In the second method, we can use the substitution u equals cos x and an appropriate Pythagorean identity to express the integrand sin³ x over cos² x dx in terms of u. So starting with u equals cos x, differentiating u with respect to x, we get the differential du is equal to negative sin x times the differential dx. Now looking at the integrand here, we have a sin³ x dx, but we need a sin x dx to appear. In order to do that, we can express sin³ x as sin² x times sin x, and sin² x is equivalent to 1 minus cos² x. So the integrand can be written as 1 minus cos² x in brackets times sin x over cos² x dx. Now we can apply the substitutions. So where we see cos² x, so there's one here in the numerator and one in the denominator, we can replace with u squared. And where we see sin x dx, we can replace with negative du. So that's our negative du here. There's the negative and there's the du. So expressing the integrand in terms of u, we have the integral of negative, open bracket, 1 minus u squared, close bracket, over u squared du. Simplifying the integrand and using negative indices where needed, we have the integral of, open bracket, 1 minus u to the power of negative 2, close bracket, du. Now the integral of 1 with respect to u is u, and the integral of negative u to the power of negative 2 with respect to u is positive 1 over u. Don't forget to add the constant of integration c. But the answer should be in terms of the variable x, not in terms of the variable u. Now we know that u is equal to cos x, since that was our original substitution. So the answer in terms of x is cos x plus 1 over cos x, which is sec x plus c.